Have you ever wondered what that invisible force is that makes two magnets snap together or push each other apart with surprising strength? It's not magic, it's pure physics, and it's happening at a level so small you can't even see it. Today, we're going to demystify magnetism and show you exactly how it works. So, let's start with the basics. Every magnet has two ends, a north pole and a south pole. You've probably heard the rule, opposites attract and likes repel. A north pole will always pull towards a south pole, and north poles or to south poles will always push each other away. But why? The answer lies in something called a magnetic field. Imagine invisible lines of force flowing out from the north pole of a magnet and looping around to enter its south pole, creating a continuous circuit. This field is what carries the magnetic force. When you bring another magnet nearby, their fields interact. If you align a north and a south pole, their field lines connect and pull the magnets together, like two puzzle pieces fitting perfectly. But if you try to force two north poles together, their field lines push against each other, creating that stubborn resistance you feel. Now, let's zoom in even further, way down to the atomic level. Most materials aren't magnetic because their atoms are all jumbled up. Think of each atom as a tiny magnet with its own little north and south pole. In things like a piece of wood or plastic, these atomic magnets are pointing in every random direction, so their magnetic fields cancel each other out. There's no overall magnetic force, but in magnetic materials like iron, cobalt, and nickel, something special can happen. These materials have regions called magnetic domains. Within each domain, all the atomic magnets are naturally aligned, pointing in the same direction. It's like having little neighborhoods where everyone agrees on which way to face. Even so, in a regular piece of iron, these domains themselves are randomly oriented. One domain might point up, another down, another left, and so on. So, again, the overall magnetic effect is zero. The piece of iron doesn't act like a magnet. This is where the magic happens. To create a permanent magnet, you expose the iron to a very strong external magnetic field. This powerful field forces all those individual magnetic domains to turn and align in the same direction. Suddenly, you have trillions upon trillions of atomic magnets all pointing the same way. Their tiny magnetic fields add up, creating one large, powerful magnetic field that you can actually feel. Once aligned, the domains in materials like neodymium or ferrite get locked in place. That's why a permanent magnet stays magnetic even after the external field is removed. Its atomic level structure has been fundamentally changed. So, when you see a magnet sticking to your fridge, what you're really witnessing is the result of countless atoms all working together. The aligned domains in the magnet create a field that temporarily aligns the domains in the metal of your fridge door, causing them to attract. It's this beautiful, organized alignment of atoms that gives magnets their incredible power. From tiny atomic spins to the giant magnetic fields that guide our planet, magnetism is one of the fundamental forces of the universe. It is a perfect example of how order at the microscopic level can create powerful effects in the world we see and touch. Thanks so much for watching. If you enjoyed this deep dive into the world of magnets, don't forget to hit that like button and subscribe for more science explanations. Let us know in the comments what other scientific mysteries you'd like us to unravel. See you next time.